All right, so the first step in this problem is that I'm going to write the equation with fractional exponents. So I'm going to write x to the 1/2 plus y to the 1/2 equals 4. Then I'm going to take the derivative of both sides with respect to x here, and we will see what we have here. So the derivative here, you're going to multiply the coefficient of 1 times the exponent. So we'll get 1/2 x, reduce the exponent by negative, or by 1. So we'll get negative 1/2. And then same thing here. This is basically the chain rule. So the outside function, I'd have 1/2 y to the negative 1/2, but then I need to take the derivative of the inside function, which is y, which is going to be the derivative of y with respect to x. And then here, the derivative of a constant is equal to 0. Now, before I go any farther, I'm going to clear the fraction that I have here. I'm going to clear the 2. So I'm going to multiply the equation on both sides by 2. And I'm going to have x to the negative 1/2 plus y to the negative 1/2 equals 0. Or equivalently, 1 over x to the 1/2 plus 1 over y to the 1/2 equals 0. Oh, and there should be dy dx right here. Okay, so if I'm going to solve for dy dx, I'm going to subtract 1 over x to the 1/2 from both sides. So I'll have 1 over y to the 1/2 dy dx equals negative 1 over x to the 1/2. Okay, I can then solve for this by multiplying both sides by y to the 1/2. So multiply both sides by y to the 1/2. This will then cancel, leaving me with dy dx, and then this will be negative y to the 1/2 over x to the 1/2. Or equivalently, you could also write it as negative the square root of y over the square root of x. Or even you could write it as negative the square root of y over x.